We want to start by graphing y equals -2 sine x on the interval from 0 to 2 pi. So when we start to graph a trig function, what we want to do is identify what is its period, because our trigonometric functions, sine, cosine, tangent, secant, cotangent, those are all periodic functions. So for sine and cosine, the period is the formula 2 pi over the number in front of x. So in this case, that's 2 pi over 1. So the period is just 2 pi. And after we identify the period, which is the time it takes to complete one full wavelength of a sine function, we want to divide it into 4 equal parts so that we can accurately label our x-axis. And a nice way to do that, to divide something into 4 equal parts, is to multiply it by 1/4. So 1/4 times 2 pi is going to simplify to 2 pi over 4, or pi over 2. So these x-axis tick marks are going to go up by pi over 2, starting after 0. So we have 0 is of course the origin, and then the tick marks are going to go up by pi over 2. So 1 pi over 2, and then next is going to be 2 pi over 2. Well, 2 pi over 2 just simplifies to pi. And then next is 3 pi over 2, and then 4 pi over 2, which simplifies to 2 pi. And then 5 pi over 2, and so on. And we can also move to the left, which would make those values negative, so negative pi over 2. So that's going to tell us how to label our tick marks. And again, so one full period ends at 2 pi here. All right, so now, once we've identified the period and then how to divide the period into 4 equal parts, now let's make sure that we remember some facts about these sine and cosine graphs. Well, the number that's in the front of the function, the absolute value of that number, is called the amplitude. So positive 2 is the amplitude of the function, which means the height of the sine wave. And that negative we're considering separate because that's going to cause a reflection. So there's going to be a reflection over the x-axis. All right, so now let's get going here. So we're going to label the y-axis with some values, 1, 2, 3, -1, -2, -3. And there's just some facts that we need to recall about the sine function. The sine function starts at the origin. And from there, at the first tick mark, right? So we've spent the time finding the period, labeling our tick marks. After we plot the point at the origin, at the first tick mark, we're typically going to go up to the amplitude when the amplitude is 2, but since there's a reflection over the x-axis, we are instead going to go down to -2 as our next point. And then we're going to return back to the x-axis at the next tick mark. So I'm going to be at pi 0. And then at 3 pi over 2, at the next tick mark, that's when I'm going to be up at positive 2. And then I'm going to end where I started at the end of the period. I'm going to be back at the x-axis. So in a length of 0 to 2 pi, that's how long it takes to complete one full sine wave. So I'm going to go ahead and sketch one full sine wave here. So that's informally one full up and down. So I have graphed -2 sine x on the interval from 0 to 2 pi. That happened to be one period of this graph. Of course, the graph does continue to go on, so this would be a periodic function that continues, but we're only told to sketch this between 0 and 2 pi. Now we want to graph y equals 1 plus cosine 2x on the interval from 0 to 2 pi. So again, we're going to start by thinking about the period, and the formula for that is 2 pi over this number that's multiplied in front of x. So 2 pi over 2, that's pi. So in a length of pi, I'm going to have one full wavelength for the cosine function. Again, to determine our tick marks, we want to have 1/4 of this value, so 1/4 of pi, Well, that's just pi over 4. So each of our tick marks are going to have to be pi over 4. So that means we're going to have to split these in half here. So this right here is going to be pi over 4. Then this is 2 pi over 4. Next we'll have 3 pi over 4. And then 4 pi over 4, which is pi. But I want to go all the way to 2 pi, so I'm going to keep on going. So I'm going to have 5 pi over 4. This one is 6 pi over 4. The next is 7 pi over 4. And 8 pi over 4 is 2 pi. All right, but we want to remember one full period happens between 0 and pi. All right, so now let's determine the amplitude. The amplitude of this function is 1. The number multiplied in front of cosine is 1. So that's the height of the wave. The amplitude is 1. And then finally at the end there's going to be a shift up 1 unit. So remember, when we're adding to a function on the outside, it's a vertical translation. All right, so let's jump to it. Let's label our y-axis. And we'll start plotting some points here. So to graph cosine, cosine starts at its amplitude. Sine starts at the origin, but cosine starts at its amplitude. So we're going to start up here at 1. And then at the next tick mark, we're going to go back down to the x-axis. Then we're going to go to negative of the amplitude, back to the x-axis, and then we're going to end where we started up at the amplitude. So it kind of looks like a V shape of points, but the way that we're going to connect those points, right, is that curved sine wave that looks something like this. So this is one full period of this function, except for the shift up, but this is one full period. We wanted to graph this on 0 to 2 pi though, so we're just going to repeat this pattern, right? We're going to go back down to the x-axis, down to negative of the amplitude, back to the x-axis, and then end where we started, back up at 1. So now I've graphed 2 full periods between 0 and 2 pi. And the last thing to do is shift everything up 1 unit. So I'm going to shift all of these points up. Again, it sort of looks like I'm making a V shape of points. But the way that I'm going to connect it, though, is with curves. So this should not look like sharp turns. They should be nice, smooth curves. That is the cosine wave. So this is my graph of 1 plus cosine 2x. It's 2 periods of it graphed on 0 to 2